In section R.3 this week, we're going to be talking about something called polynomials. We're going to be doing addition and subtraction of those polynomials. Next week, we'll be talking about multiplication and factoring. The definition of a polynomial is what's listed here below. In one variable, the exponents of each one of these variables is going to be a non-negative integer. The numbers 0, 1, 2, 3, etc. There would be a number in front of those letters, which could be any real number. So there's an example of one, 2x to the 5th plus 3x to the 4th, etc. What's probably more descriptive of it is to describe, give examples of it. So here are some more examples of polynomials in one variable or one letter. With each of them, you see that they all have a 0 exponent or an exponent that's bigger than 0, and they all have numbers in front of those letters. Examples of ones that are not polynomials in one variable are such as these. This one is a polynomial in two variables, and the bottom one, 1 over x to the second, is not a polynomial. You cannot have variables in the denominator of a fraction. The definition of it isn't terribly important, but as we go through, we're going to be talking about them, so I just kind of wanted to give you a brief introduction to what we're going to be talking about. What's very important is to understand the definition of what a term is. A term is going to be a real number, a variable, or a product or quotient of variables or numbers. So what product means is multiplication. What quotient means is division. Terms are always going to be separated by plus or minus signs. You can actually think about those plus or minus signs as creating like islands that you can work on the things that are in between the plus or minus signs as if they were islands and kind of self-contained. The first expression that we see there has three terms. Those terms are 5x to the second, a negative 3xy, and a negative 7. The sign always goes with the term. Whether it's a positive or a negative sign, it always goes with it. So the first term is a positive, the second term is minus, has a minus 3 in front of it, and the last one is the negative 7. How many terms are in that expression right there? So it actually has 4 terms, and those are listed as you can see them. What a coefficient means is any factor or which is a multiplier in a term is the coefficient of the remaining terms. So if we have the term 4x to the second y, the coefficient of y means everything that it's multiplied by except for the y, which is 4x to the second. The coefficient of 4 would be everything except for the 4, which is x to the second y. On page 3 of your handout, lecture notes, you will see what we're going to be using as the coefficient. Normally when we talk about coefficient, we're talking about the numerical coefficient, that is the number only. So for the rest of the lecture notes, whenever I say coefficient, I'm going to be talking only about that numerical, that number that's in front of the variable. The coefficient, it's very important to realize that it always includes the sign. That means whether it's a positive or a negative. So in this example, the coefficients of that polynomial are 8 for the first one, negative 12 for the second one, and a positive 1 for the third one. The next example that you see here, the coefficients are negative 3 for the first term, a negative 1 for the second term, and a 0.5, a positive 0.5 for the third term. We were previously talking about polynomials in one variable. Polynomials can also have multiple variables. So you can see an expression, an example of two polynomials in two variables listed here. We're going to be talking about what the degree of a single term is, and the importance of a degree is that it allows us to categorize different polynomials so that they graph in different ways, that we work their problems in different ways. For the purposes of this class, most of the ones that we're going to be dealing with are going to be something called degree 1. There are examples in your textbook that you can take a look at of things that have higher degrees than that. But let's go back to item 1. The degree of a term is the sum of the exponents of a term. So as we look at this expression, 7a b to the third minus 11a to the second b to the fourth plus 8, there are three terms in that expression, and the three terms are listed there. What is the degree of the first term? The degree of the first term is equal to a 4 because the exponent of the a is a 1, the exponent of the b is a 3, 1 plus 3 is equal to 4. On the second term, the degree of that is a 6 because the exponent of the a is a 2, the exponent of the b is a 4, 2 plus 4 is equal to 6. The degree of the third term, which is the 8, is actually a 0. Any number has a degree of 0, so the degree of 8 is equal to a 0, and that's because 8 is equal to 8x to the 0. Remember the last class we had that x to the power of 0? Actually, it was this class, it was the previous section. X to the power of 0 is equal to a 1, so its exponent is actually a 0. That's why the degree of any number is a 0. So that's how you tell the degree of an individual term. The degree of an entire polynomial is going to be the same as the degree of the term that has the largest degree. So on the example above, the degree of the first term was 4, the degree of the second term was 6, the degree of the third term was 0. The largest of all those numbers is a 6, so that makes the degree of the polynomial be a 6. This is how you're going to do homework problems 1 through 4 on section R.3. So make sure that you look at this example and understand it. You go through, you give everybody an exponent, like on the 7ab, make sure you give the a an exponent of 1. You add up the exponents of each individual term, and then you look at them separately and take the largest one. You do not add all of them together. It's going to be the largest degree only. So here are several examples that you can try right here, and the answers are listed below for you. So you can stop, pause the video, and try these problems and make sure you understand them before you go on. Polynomials are usually written in descending order, which means for the expression that you see on the line there that follows would usually be written is an example of something that's kind of in not in order. How it would be typically written is on the line below, where the exponent on the y is an 8. That's the largest one. It would be listed first. The exponent on the next term is a 4. It's listed second, and then the ones with the y to the second powers are listed next, and then lastly the numbers. So we've been talking all through class about how things are listed, and we know that in a term we normally list letters in alphabetical order. When we have terms, we usually list those terms in descending order of the degree of the term. So again, we see that degree plays a part in listing those in descending order. You'll remember back to the first class that we have the associative property and the community property, and that allows us to turn these around and associate different things together and put them in that order. There are certain polynomials that have special categories. A monomial has one term. A binomial is like a bicycle. It has 2 terms, and a trinomial, like a tricycle, has 3 terms. On page 5 of your handout is a very important description, and that description is of like terms. Those terms are terms that have exactly the same variables, and those variables have exactly the same exponents. So examples of like terms on number 1 are 3x and 7x. If you cover up the numerical coefficient, you could not tell the difference between those two terms. Likewise on problem 2, if you cover up the 3 and the negative 2, you couldn't tell the difference between them. On example number 3, you'll notice that the third term that's there has the z and the y turned around. Remember, because the commutative property of multiplication, we can turn those two around, and therefore if you cover up the 2, the negative 7, and the negative 5, you couldn't tell the difference between any of them. If any single variable is different or any exponent of any variable is different, they are not like terms. We're going to stop here and then continue on the next video.